Aspirin can be produced by reacting salicylic acid with ethanoic anhydride. An incomplete method to determine the yield of aspirin is shown. Add about 6 grams of salicylic acid to a weighing boat. Place the weighing boat on a 2 decimal place balance and record the mass. Tip the salicylic acid into a 100 centimetre cubed conical flask. And then we've got our step missing. Then it says add 10 centimetres cubed of ethanoic anhydride to the conical flask and swirl. Add 5 drops of concentrated phosphoric acid, that's going to be our catalyst. Warm for 20 minutes, add ice cold water and place in an ice bath. Filter off the crude aspirin from the mixture and leave it to dry. Weigh the crude aspirin and calculate the yield. Describe the instruction that is missing from step 4. So they've put the 6 grams in the weighing boat and recorded the mass of the weighing boat and the 6 grams, and then they've tipped the weighing boat into the conical flask. They need to re-weigh the weighing boat to get weighing by difference. And that allows them to calculate the exact mass of salicylic acid added to the conical flask. So that's the exact mass used. State a suitable piece of apparatus to measure out the ethanoic anhydride. So the ethanoic anhydride is likely in excess because we would be using the 6 grams of salicylic acid to determine our yield. And so if we want to add 10 centimetres cubed of something that is in excess anyway, we could just use a 10 centimetre cubed measuring cylinder. You could use a pipette, but you wouldn't need to be that accurate if this is in excess. Identify a hazard with a concentrated phosphoric acid. Well, we know that the concentrated acids are corrosive. Complete the equation for the reaction of salicylic acid with ethanoic anhydride. So remember, the anhydrides are those that are like 2 ethanoic acids that have come together and lost water. So that's our structure of ethanoic anhydride. We can see that this is the bit that we've kind of added on. That's come from here. So the other product that's left over is a CH3, C double bond O, O, and then it got the hydrogen from the alcohol group of salicylic acid. 6.01 gram sample of salicylic acid is reacted with 10.5 centimetres cubed of ethanoic anhydride. In the reaction, the yield of aspirin was 84.1%. The density of ethanoic anhydride is 1.08 grams. Show by calculation which reagent is in excess. So let's do moles of salicylic acid first. 6.01 over 138. So we type that into our calculator and get 4.36 times 10 to the minus 2 moles. Then let's do moles of the anhydride. And that is 10.5 centimetres cubed times the density to get the mass divided by the MR that they've given us. And that's coming to 111, I think. Let's just check that on your calculator. 0.111 moles. So we can see that the reagent in excess is ethanoic anhydride, which is what you would expect in an experiment like this. And we know that because 0.111 is bigger than 4.36 times 10 to the minus 2. So the moles of aspirin expected would be 1 to 1, so 4.36 times 10 to the minus 2. But the moles of aspirin that we actually got was 84.1%. So 84.1 out of 100 times 4.36 times 10 to the minus 2. So we get that on our calculator, 0.0367. And so the mass is Mr. Moles, MR times moles. It's given us the MR of aspirin as 180. So we're getting 6.60 grams. Suggest two ways in which the melting point of the crude aspirin collected in step 9 would differ from the melting point of pure aspirin. Well, the value of an impure sample would be lower because the impurities disrupt the intermolecular forces and pockets of the sample then start to melt at a lower temperature. Some pockets of the sample will not have impurities and melt at the correct temperature, so there will be a range of values rather than a specific value. Crude aspirin can be purified by recrystallization using hot ethanol as the solvent. Describe two important precautions when heating a mixture of ethanol and crude aspirin. So because ethanol is flammable, we would use a water bath to heat or an electric heater, but not a Bunsen. And we would heat to a temperature lower than 78 degrees C to avoid it boiling. The pure aspirin is filtered under reduced pressure. A small amount of cold ethanol is then poured through the Buchner funnel. Explain the purpose of adding the cold ethanol. Well, the cold ethanol is to rinse it and to remove any impurities that are soluble, that are in the liquid that surrounds our solid aspirin. Sample of crude aspirin is kept to compare with the purified aspirin. Describe one difference in appearance you would expect to see between these two samples. So it tends to be that our pure product has larger, more needle-like, whiter crystals. So any one of those three would probably get you the mark.